What's up, everybody? Welcome to another episode of the AI Marketing Navigator. This is your daily compass in the ever-evolving world of AI marketing. I have been having some weird audio tech issues, so apologies if today's audio is off. If it is, please adjust your audio as necessary to get the best quality. Hopefully this turns out a-okay. Anyway, so for today's episode, I wanted to talk about a recent update from the Google Gemini team uh, from yesterday, June 27th, regarding Gemini primarily is what I wanted to talk about, but also Gemma. They announced alongside of some Gemini news, some Gemma news. Now, you most likely, like me, have heard of Gemini, Google's flagship AI model. I've used it in a few examples, and I've mentioned it a couple times in the show, I believe, but you also, like me, may have not have heard of Gemma. Gemma is Google's family of open source lightweight AI models for generative AI. So you're probably also thinking like me, again, that uh, like when I first learned about this, that I thought Gemini was the whole open source that had free tiers and it was supposed to be available for everybody. And it sounds like that's really Gemma's mission and purpose. So yes, it's true. That was also Gemini's purpose, but it sounds like Gemma has a slightly different purpose and serves a little bit different goal as well. Well, Gemini is Google's flagship model, and it's designed to be definitely its most powerful and versatile. Gemma is all about accessibility and agility, really. You can kind of think of it as the Gemini for everyone. Gemma models are smaller, they require less computational power, and it really makes them ideal for deployment on a wider range of devices. So things like from your laptop to your phone, maybe out of date Chromebooks or slightly or devices with a little less processing power than we might typically expect these models to run on. It really seems to be much more developer focused. Gemma, that is, has much more of the feel of an open source project. So anyway, what about this update? Well, part of the update was about Gemma 2, this open source model, or excuse me, Gemma. They released Gemma 2, and it's the latest addition to this family. And that led me down a couple avenues that I wanted to touch on before we got to the Gemini um, improvements and updates. And I'll try and continue to project here so the audio uh, turns out. There are two sizes to this Gemma 2 update, a 9B or 9 billion parameter size and a 27B or 27 billion parameter size. And when I first was learning about this, I naturally wondered, okay, what is this word parameters that keeps coming up in the context of these models and what exactly are they referring to? And so in simple terms, a parameter, you can just think of it as a numerical value that an AI model learns during its training process. Excuse me, yeah, they're numerical values used by an AI model to learn during its training process. You can think of them kind of like the settings of a machine, a complex machine. Each parameter is going to influence how the model interprets input and generates output. Imagine like the human brain, for instance, a vast network of interconnected nodes like neurons or something like a giant web, and each connection in this web has a weight or a strength assigned to it, and it's represented by these numerical values. These numerical values are the parameters of these models. And during training, during the learning phase of these models, they're going to adjust these parameters. They're going to strengthen some connections between certain uh, information and weaken other weights connecting certain information to learn basically the relationship between these items and the patterns and relationships within the data that's being fed to the model. In the case of large language models like Gemini or Gemma, these parameters are really responsible for understanding the meaning of the words, the grammar of the sentences, and the context of entire paragraphs. They are, in essence, the knowledge about that the model has accumulated about language. Okay, so that's all well and good and cool. I mean, 9 billion parameters, 27 billion parameters for Gemma, but as a marketer, I'm not using Gemma at this point. Right now, I'm using Gemini. I need the power and the versatility that they market with Gemini and to accomplish the more complex problem solving, like aiding in something as nuanced or that takes as much back and forth as crafting a marketing strategy, for instance. And so the other part of the update, the much more important part to us as the marketers, and the actual reason I wanted to record this episode, is the new Gemini 1.5 Pro access or open access to what they're calling a 2 million token context window. And so that leads me down another avenue that I have been going down, and that's what are tokens in the context of these AI models, because you're going to come across that a lot as you learn more about these AI models, just like I am. And you can think of the tokens as like the fundamental building blocks that these models like Gemini are using to understand and process language, a little different from parameters. Um, According to a featured snippet from an article by Functionalize, I believe. I'll link to the article here, of course, in the show notes. They say tokens represent the smallest units of data that the model processes, such as the words or characters in natural language processing, NLP, which we've learned about. Well, parameters, on the other hand, are the internal variables that the model is adjusting and giving these different weights and different relationships during the training to improve its performance. So different categories there of numerical values. So imagine like taking a sentence and breaking it down into individual words or punctuation marks or even parts of words like the syllables or something. These chunks are what we're going to call like the tokens. In the world of AI, these tokens are like the building blocks of the language, like I mentioned. And Gemini, these models, they manipulate and combine them to generate meaningful, contextual, relevant text in response to your prompts. For instance, the words digital pop might be broken down into digital and pop, or digital and pop. These tokens are converted into numerical representations that the computer can understand, ones and zeros, basically. The more tokens a model can handle, the more context it can take into account when generating text, when dealing with the prompts you're giving it, the better its memory is, essentially. So the larger its context window is, which brings us to another key aspect of these AI models, and that is the concept of these context windows. And this is essentially the amount of information that the model can remember while generating text, while dealing with a problem you presented it. You can think of it as its short-term memory, if you will. And the size of this context window is often measured in these tokens. And Gemini just took a huge leap to the front of the pack. Actually, to be honest, they've been in the front of the pack, as you'll learn here in a bit. And to put it into perspective, I actually found a great Reddit post that I will link in the show notes, and it just gives a quick breakdown of how crazy fast these context windows have scaled up. It goes all the way back to 2018, which goes back to a time when I was unaware of some of these models. But I'm going to mostly talk about some models that we've heard of, talked about, or should be familiar with here, like Claude or GPT-4, GPT-4o. And to put it into perspective, the original GPT-4 context window had around 8,000 token, an 8,000 token context window. Claude crushed that by jumping to 100,000. I'm pulling these numbers from this great Reddit post here as well. And then ChatGPT came out with ChatGPT 4o, and this was just recently, and it roughly had a context window of 128,000 tokens. So huge jump there. And then Claude 2.1, again, in the race of context windows, if you will, jumped from 100,000, their previous window, to 200,000. And then again, way out in the lead was Gemini with a context window of 1 million tokens. And now they just announced that it's become 2 million tokens. So they literally just doubled it. They've doubled the memory of Gemini, essentially. I don't know. I'm pretty strong on the Gemini bandwagon as far as my model of choice at the moment. Okay, random tangent. You can consider it a postscript to this episode, if you will. You'll probably notice if you check out that Reddit post that it lists a max content window, or maximum, excuse me, I always mix that up, a maximum context window for Gemini 1.5 of 10 million tokens. So obviously I was like, what the heck is that all about? What is this super godlike 10 million token memory that we could be using? And it turns out that the previous 1 million context window, 1 million token context window, I'm going to be tripping all over those words for the entire episode, which is now 2 million, was what they're calling an extended context window. Well, the 10 million number is a theoretical maximum context window. So what's the difference? Well, I just decided to ask Gemini itself what the difference was between its 2 million context window and its 10 million context window. And I'm pretty impressed with the results, actually. Here's what Gemini told me about itself. It said, Google hasn't publicly released the specifics on how the extended context window functions within Gemini 1.5. However, based on current information and how similar features work in other models, we can infer two possible interpretations. So it's actually breaking down without the true facts of the situation, which is strange because it's Gemini and it's Google. It doesn't know its true powers, which, I'll let you just read into that as you will. But its first interpretation here about the difference between why there is a difference between this extended and maximum context window is just hardware and software limitations. The maximum context window in this instance could refer to the absolute limit, the absolute max of this model's architecture. It's the largest amount of information that Gemini 1.5 can theoretically handle due to its underlying design and the actual hardware that it's running on. Like, hey, if we push this to the max of what we actually can build for it to run on, what could that theoretically look like? And it goes on to call the extended context window, in this instance, a feature that lets perhaps users utilize a larger portion of that maximum, but with the potential trade-offs. So for instance, using more of the maximum might lead to that increased processing time. So I think what it's trying to say here is essentially, hey, we could give you like 10 million, but it's going to take forever. Why wouldn't we just give you 2 million and it will be almost instantaneous and the results aren't even that much worse, which I don't know, that might be doubtful. And that's kind of where I think we're going with this episode, and I'll let you decide when we get there. So the trade-offs could be this increased processing time, higher resource usage, like more memory or computational power being needed. That's why they're offering this extended versus maximum, or limited just availability. Maybe this feature might only be offered to very certain users. I mean, that's the case for these upgraded token levels. I mean, 1 million is only available to certain users apparently, and 2 million. And of course, obviously, I don't know who's messing around with the 10 million, but they must be having quite the conversations with the artificial intelligence. The second interpretation that Gemini gives for its own difference is dynamic allocation. So again, I'll just give you a breakdown of what Gemini says here. It says the maximum context window in this dynamic allocation example could represent the total memory pool available for storing past information, the context. Well, the extended context window, this could be a mechanism that actually dynamically allocates a portion of that memory pool based on user needs. The amount used could vary depending on, it says, the task. The complex tasks might obviously need more context than simple ones, and that could be allocated dynamically, and it's going to need that reserve of 10 million to do so. It could be the resource availability. Again, if the system is under a heavy load from a lot of users, then less memory might be allocated. Well, if it's under a light load, more memory can be allocated. So anyway, it also has an opinion on why this distinction matters, which I find particularly interesting because, again, we're asking Gemini this question about its own context windows, and it's telling us, well, this is why it's important to note the difference between the small one and the big one. It says, understanding the difference is crucial for developers and users. Developers, they need to know the limits of the model when designing applications. Is there a hard cap, or can they push the boundaries if they're willing to accept the trade-offs? So, again, it's interesting. Gemini is saying, hey, what's going on here? The developers should know my limits. The developers need to know, hey, are we building apps that can eat up the entire 10 million token window, or are we building apps that have an entire 10 million token window only available to take off, and they all have to share that? What are the bounds that we're working within here? Gemini goes on to say that users need to understand this difference. They need to understand what to expect in terms of performance and cost. Will using this extended context always be slow or more expensive? And I kind of read this as, is this value being manipulated by Google? Are they kind of like holding these reserve tokens like, hey, Yeah, we have 10 million, but we're only playing around with 2 million right now, and we're going to see how much we can charge people for those 2 million before we start doling out the other 10 million, like the diamond market or something what is controlled, or who knows what exactly the motivations might be. um, but this is Gemini again giving us some additional notes here. It says in some additional notes to that question, Gemini 1.5 Pro, this is the version with the most expanded context capabilities right now. So this is, I believe, what I'm running with as a pro user on Gemini. And it's available with the standard 128,000 token window. But and that's actually the rate if we go back of the chat GPT 4.0 right now is running at that 128 token, 1,000 token window. So it sounds like ChatGPT 4.0 and Gemini 1.5 Pro for most users right now are about the same. But a select group of developers and enterprise customers can access up to 1 million tokens in a private preview. That was the case, apparently. So this might be a little outdated, this information from Gemini, because apparently now it's 2 million tokens for some of those enterprise customers in a select group of those developers. Gemini continues. It says, it has a category, or excuse me, a section of research hints. There are intriguing hints that at 10 million tokens, so at that maximum token level, in-context learning with Gemini becomes dramatically more effective. Well, I would think so. If 2 million is far and away better than the best models we're running with right now, then 10 million has got to be pretty darn impressive. And it goes on to say that this could be a future development, but it's currently unconfirmed. Yeah, I think that the 10 million is got to be pretty impressive. I mean, if I have to wait a month to solve a big enough problem, I think that people are going to be willing to wait as long as it takes if this thing can solve some of the problems that it might be able to tackle for not only humanity, but let's just keep it solely down to marketing. I mean, it could be very, very powerful. So anyway, it gives us the bottom line here as well. Without official documentation, we can only speculate. Both interpretations highlight Gemini 1.5's ability to handle larger contexts with standard settings, which is a significant advancement in the field of AI. It says, I hope this explanation is helpful. Again, I found it pretty darn helpful, and I was impressed with the level of detail and nuance actually in how it kind of handled, considering the lack of concrete information, how it handled that question. Now, take it with a grain of salt. It is Google talking about Google. So anyway, there you have it. That's it for today's episode. Tons of crazy information about these AI models thrown at you, but I had a great time talking about it. I hope you enjoyed it as well. If you did, or you found it useful in any way, do me a favor and follow on Spotify or subscribe on your podcast platform of choice. A review on top of that would be even more helpful and appreciated. So helpful to the show. So until next time, thanks for joining me, and remember to stay curious, stay consistent, and keep navigating forward. Bye.